All right, hey folks, you got solving from factor form number 3 on slide 17. I'm getting some questions about this, and figured I'd talk about it a little bit here, give you a little context for this. I'll give you the quick answer in written form when I send this video out, and then also the longer answer here. So this one you're dealing with trying to use the zero product property. Well, this is written in standard form. What do I do first? I change it to factor form, and we also want to get it set up equal to 0 because we're trying to find our x-intercepts. To get the zeros of the equation, the zeros in the graph, right? The x-intercepts here. So the goal is to get it written out like this, right? If I can factor it, I should be able to get it written like this. Then I can use the zero product property, set this factor equal to 0, solve, set that factor equal to 0, solve, and there. And that's what you've learned this lesson, okay? So anyways, I got this one set up here. Again, the diagonals of that rectangle, I got to multiply to be the same product. That's how we can set up a rectangle using our polynomial. So anyways, we put the 6x squared down here, put the constant term up here, negative 15, multiplies together to be 90x squared, and then you have negative 11x's to work with. So here you got, you might have run into a problem here, and I'm going to tell you, you're right? This one here, not factorable. Okay, not factorable, right? If we got factors in 90, here's how I go through to make sure it's not factorable. Well, I got 2 times by 45. Okay, is that going to help me get to 11? No, 2 and 45 get you 43, get you 47. Can't get there by adding here. So definitely 2 and 45 won't work out. So is it 90 divisible by 3? Yes, it is. 3 times by 30, well, that can get you to 33 by adding them together, or 27 by subtracting. And that's not good either. Can't get you to 11, so I'll cross out. 4 doesn't go into 90, right? 4 goes into 80. We're not going to go into 90, so 4 we don't worry about. What about 5? Okay, 5 goes into 90. Sure it does. 5 goes into 120 times, so it'll go into 90 18 times. So that'll get you up to 23, or it could bring you down to 11, because remember, one of these has to be positive or negative. So it could get you to 13, right? 18 minus 5 is 13. So you could get to negative 13, get to negative 11? No, you can't. So it's not going to work either. What about 6? Does 6 go into 90? 6 does not go, does it go into 90? It does go into 90. Actually, yeah, 6 goes into 90 15 times. So anyways, does that get you to 11? No, it doesn't. Okay, no, it doesn't. It will get you to 9, right? It's 15 minus 6 is 9, so not 11. So not too good to go there. And then 7, does that go into 90? No, it doesn't. Does 8 go into 90? No, it doesn't. Does 9 go into 90? And that'd be the last one. Once you realize the numbers are right next to one another, that'd be the last one. 9 goes into 90 10 times. But that gives you to 19, or it gets you to 1. It doesn't get you to negative 11. So that's not working either, okay? Go up to 10, right? Oh, we have 10 here. It goes to 99 times. We're repeating here. So 11 doesn't go to 90. 12 doesn't go to 90. 13 doesn't go to 90. 14 doesn't go to 90. 15 goes into 90 18 times, okay? 15 goes into 96 times. So anyways, we begin repeating there. So, hey, this is not factorable, this one, okay? Not factorable. So the deal with this one, and we'll study this one a little bit later, is that we actually need to develop other methods, right? There are going to be some other methods. You better believe there are going to be some other methods, not factorable, okay? There are going to be some other methods that will allow us to solve for these zeros here. So the way I write this out, and I'll send this all to you to please put this into the slides here. Hopefully you watch the video is, let's see here. We cannot use the zero product property, right? Which factoring, right? Factoring. Because the polynomial y equals 6x squared minus 11x minus 15 is not factorable. If we cannot write the polynomial in terms in a form using its factors, we cannot set a factor equal to 0. Right? If we have no factors of this polynomial, it's actually something called a prime polynomial, right? This is actually something called a prime polynomial. It can't be factored. So if we can't factor it, then at least in algebra 1 we can't factor it. There we go. Then we can't use this. We can't set those factors equal to 0, which is the whole point of the zero product property. We cannot write the polynomial in a form using its factors. We cannot set a factor equal to 0 and solve for x. Solve for x. So we do not know what the zeros are of this equation. It's an equation here because we have an equal sign here. We do not know what the zeros are of this equation at this time. Okay? Perhaps we will learn a method or two in the coming weeks that would allow us to solve for the zeros or solve the equation, right? 0 equals 6x squared minus 11x minus 15. Okay, so hopefully there's another method there because there are probably zeros. There are probably zeros. It's kind of awkward, right? We get into a world where it's kind of this unknown with this quadratic thing, solving quadratics. So there probably are values of x that would make this, yeah, there would be, make y equal to 0. There probably are. We pop this onto a graphing calculator on Desmos, we'll probably see a couple x-intercepts. But those x-intercepts are going to be a little more complex. Like they're going to be a little more confusing. They're actually going to be something called irrational as opposed to rational, irrational x-intercepts, okay? They could be imaginary. That's another thing too, imaginary numbers. Oh, but here, write your solutions here. We don't know yet. And that's that, okay? Thank you for watching this video. I'm gonna send out this explanation that you can use, copy paste, put it in, but hopefully you understand why you can't use the zero product property to solve this one right now. It's not factorable, okay? There'll be a different method coming later. Quadratic formula. Bye.